We're being asked, first of all, to verify the curve intersects the x-axis at 9, 0. That's going to mean we need to set y equal to 0. That's where we get the intersection. So we need to solve this equation. 1 minus 3x to the minus a half equals 0. Another way of writing that is 1 minus 3 divided by the square root of x equals 0, which we can rewrite as 1 equals 3 over root x times through by root x. It must be that root x equals 3, and therefore x equals 9. And what we've just shown is that this here is 9. We've now got this shaded region. And it's enclosed by the curve, the x-axis, and the line x equals a, where a is greater than 9. Given that the area is 4, find the value of a. So we can create an equation here. It must be that the integral from 9 to a of 1 minus 3x to the minus a half is equal to 4. That's what we're being told. So we can create an equation in terms of a. Well, we have done that, but now we can integrate and substitute in for a, and we can solve for that. So I'm going to integrate this function. It's going to become x. Right, I need to raise the power by 1 and then divide by the new power. So if I divide by a half, it's the same as times in by 2. I'm going to get a minus 6 here. We can check that. If we differentiate, it's going to be a half times 6. Yep, I get the 3. That's going to work out, and then I put my limits in, my definite integral. I know my a's and 9's look quite similar. Okay, substitute into a. It's going to become a minus 6 a to the half. When I substitute the first limit in, minus, I'll put that in a bracket, 9 minus 6 times 9 to the half equals 4. A minus 6, okay, I'm going to write it as a square root of a, I think, just to, why not? And then it's going to become minus 9 minus, now this is actually the square root of 9, it's going to be 3, so it's minus 18. So that's going to become minus 9, it's going to become plus 9. Okay, there we go. This is in fact a hidden quadratic, so because what I have essentially is root a squared minus 6 root a plus 5 equals 0. So I can either factorize in terms of root a, or I can do a substitution, let t equal root a, then we'll get t squared minus 6t plus 5 equals 0. And after all this, we've got a quadratic to factorize. It must be that t, okay, both of these have to be negative, they have to add to give minus 6, it's going to become t minus 1, t minus 5. T equals 1 or 5. Now don't forget that is the square root of a, so it must be that the square root of a is equal to 1 or 5. So a, if I square, a is equal to 1 or 25. And we're nearly there. So we're told, remember, that a is greater than 9. We found a value over here as well, but actually we only care about the one that's greater than 9. So reject this one. A is equal to 25. Good question. Integration, hidden quadratics, the lot. What a question.